I'm Jared Redelman. I get to work with our project controls group. As most of you know, our project controls group also takes on some of the VDC and technology role for the organization as well. As we've rolled out things like drones and laser scanners, and most recently the mixed reality with the HoloLens, we have seen that put to use in industry applications. Internally, we've used a lot of that technology outside of Bowen with outside services before we have purchased it. And we've seen the value and the benefit of that, and we wanted to make that more readily available to all of our project teams, to where we're not working with outside services, paying higher fees, paying more exorbitant amounts of money that most of our projects may not be able to handle and absorb.
A HoloLens is a little headset you put on, and it's a mixed reality headset. And what it allows us to do is we can load designs into that headset and walk around, and it's called mixed reality because you've got your computer design that you're able to load into the program, and also be able to see through your visor the real space that you're in. So you can, on a job site like this, we can walk into the building and see, okay, this ductwork is running right next to this steel, and actually this steel runs out a little bit farther than it's supposed to, so we need to move that ductwork over a little bit.
Putting that HoloLens on, we lined it all up, and I found out that one of our T-posts was hitting a valve handle. I was like, hey, there you go, that's got to be shifted over. It was something as simple as that it looks clear in the model. If you miss it in the model, they say it's good, but then you actually go walk it. There's a whole different scenario that when you actually walk something in real time, you can actually see that and physically touch something that, hey, this is probably going to be in the way, this is probably going to work, this is not going to work.
The sooner that we can identify those conflicts and resolve them, rather than having those types of conflicts in the field, it's going to save us time, it's going to save us money, and in the long term, it's going to give the owner a better finished product, so you don't have a bunch of lines looking like they were trying to avoid each other.
It takes pipe detailing to a new world, because we are essentially detailing the pipe, walking out our routing, but we are also allowed to see the model at the same time. Because normally we will do our layout on the floor, up in the rack, kind of get a feel for what the pipe is, but this actually let us see where that pipe is going to be. See, I definitely see some huge benefits from using these things, and for a low cost as well. In the grand scheme of things, this cool of technology, let's just call it what it is actually pretty affordable, and could definitely save a lot of time and help some pipe routing in some of these large mechanical jobs.
So the way laser scanners work is you have the laser scanner device on top of a tripod, and it spins around and shoots hundreds of thousands of points per second and measures all of those points, and then you're able to stitch all those together, or actually the equipment is able to stitch it all together into one image, which you can then use to take measurements. You can grab volumes or pull different measurements off of that model that it creates.
Alec Goodall, project engineer. So the laser scanner is going to be really helpful in this project, because as you can see, we've got a lot of hydronic flooring, hydronic radiant flooring that's going to heat this floor. So once we pour concrete over this, we won't be able to know exactly where all this tubing is, because it'll be covered in the concrete. So after the fact, we'll be able to map this out and accurately see where the tubing is. So if we need to do any improvements after the job, for example, anchor bolts or any type of anchoring systems or drilling into the concrete, we'll know where this tubing is, so we don't hit it and damage it and potentially have a huge problem later.
I'm Josh Thomas, project manager. At one mechanical project, we use a laser scanner to go in and see all of the existing utilities that were in the building before we started on a very complicated under boiler installation. What we were able to find is that the engineered drawings we had several of the pipe tie-ins just a quarter to a couple inches off. And when that happens, we get pipe lined up to fit in the area, the pipe won't fit, and requires rework. And so by looking at the existing model, we were able to eliminate a lot of rework and also document things that changed for change orders back to the client, and therefore saved a lot of money with the laser scanner by being able to document those claims.
Matt Gentry, operations manager out of our Evansville, Indiana office. When our competitors are routing that pipe, without having those scans and without walking all those lines down, they're probably going to be a lot more conservative at bid time, because it was, you know, it's twin 18-inch carbon steel pipes going through the middle of the powerhouse. So they're going to have a lot more guesses during the estimate phase than we will. You know, we've got a definitive route that we've used to, with our engineers, routed it through.
So many times we go out to a pre-job meeting and say, wow, I wish I had a picture of this, or wish I had a picture of that. The laser scanner will assist in capturing that information in real time, so that we can go back and evaluate that prior to a bid and hopefully find a competitive advantage.
My name's Paul Creasy, project manager with Bowen. Been with Bowen for 12 years, and we are at the Muncie Sanitary District sanitation building project. So the drone's been helpful as it captures data over time, where we need a snapshot of the entire project area at certain intervals that are critical to the job's success. One being initial baseline. Two, we had a massive site fill on this project area, somewhere in the neighborhood of 17,000 cubic yards site fill required on a very low lying area and a road abandonment. So being able to capture that information with the drone over time gives us a great lay of the land. But what it's helped us on a 2D layout is taking that drone shot and actually being able to overlay our construction design drawings to make sure we're within that framework, that our layout is correct, and we've got a really cool reference point of actual job site data to overlay on design data.
The use of the drone has been really helpful for us. We've been able to model the job from the very beginning, before we even broke ground, see what the original layout was, and then it's really helped us see us move through construction, the different views, from an overhead view that you normally don't get to see. So from ground up, we've really been able to see the job come up out of the ground, rather than just a flat surface that you look at day to day.
We use them more and more as time goes on for different things. We find different applications to use them for. We can draw maps that will GPS, and so we use that a lot at the beginning here. We had a whole lot of fill, and we can set up the map and fly the drone back and forth over it, and it maps it all itself, and then tells you exactly where you're at, cut and fill wise, what needs to come out, what needs to come in. We use it for marking underground utilities. We've used it out in Avon. You can fly that same map after they come out and mark everything, see right where your utilities are. Again, helps with the SQP, the pre-planning process, knowing right where all that stuff's at. You got a good picture of it. We also use it for a lot of marketing stuff. A lot of the citizens' jobs, we can go fly it every week, fly the same pattern, and then show the client or the owner how far we've come.